Okay, so storage with pod. We already completed one storage with container, that is volume. Now suppose this is one node, these are also number of node. Suppose one master and this 3 4 whatever, these are worker. Now sometimes container is going to create in this node. Container is down, that is pod actually, it is down, and it is going to create in this node. So worker 1 to worker 2, it is not fixed that when it is going to down it is going to recreate the same pod in the same node. It's maybe any node because it is cluster. Now question is how to manage the storage. Suppose this is my application and this is my database. Suppose application is running in this pod in node 1 and one database is running in node 2. Now this application is going to connect to this database, and database data is going to store this is a storage. What type of storage? You just consider we are continuing this practical on AWS. So this is EFS, Elastic File System. So this container is going to access this EFS. Now suddenly this container is down and container is going to create in different node. Automatically it is going to connect from here. Okay, so this is your actual storage. This storage, how we are going to access? This is storage PV PVC. So try to understand this concept. See, Kubernetes PV PVC details. PV means persistent volume. Persistent volume means if container is deleted, still my volume is going to stay there. Volume is not going to delete. And persistent volume claim, how much container is going to claim. So let's try to understand PV and PVC. What is PV? Cluster-wide resource that represents a piece of storage provisioned by an administrator or dynamically. That is, as a administrator I can mention this is my PV, or automatically it is going to provisioned. So this how to provisioning it? Static and dynamic. Static means by administrator, by us, and dynamic means automatically by the Kubernetes. So what happened? This is my EFS. Suppose this EFS There was no limit. Now we are going to create PV. Suppose manually, that is administrator, statically I am going to create one PV. So I create one PV of 2 GB, another one 5 GB, another one 10 GB, different PV. This PV from this EFS. Now this container is going to claiming one particular PV. So that is known as PVC, persistent volume claim. This container claiming 2 GB, this container claiming 10 GB. So when it is claiming 10 GB, suppose it is claiming 9 GB. So Kubernetes is going to check 9 GB is possible from this 10 GB PV, so it is going to provide here. This container is claiming 2 GB, then it is going to provide this one. But this container, if it is claiming 3 GB, my requirement 3 GB, then Kubernetes is going to provide from 5 GB. Okay. So PVC, that is our claim, how much my requirement. Pod is going to claim this much storage is required. PV, that is part, logically part by part storage, and this is actual storage. EFS, EBS, you can utilize it. And it is persistent because if your container is down, no issue, your storage is still there. So you recreate the container, it is automatically auto healing through, and container is going to access the same PV. So basically, from this is our EFS, that is our storage. This storage to PV, that is persistent volume, then PVC, persistent volume claim. This is the relation. Now when we are going to claim it, different type of options are there. Theoretically, you please go through this. First, persistent volume is static and dynamic. Two options are there. Persistent volume, either it is static, admin is going to manually create it, and dynamic, that is automatically going to create. Now access mode, different access mode is there. Read write once, read only many, read write many, and read write one spot. Mostly we are going to use this first three. What is the meaning? Read write once can be mounted as read write by a single node. If I create one particular PV, suppose here it is example PV for as a 10 GB. This PV, if I utilize it, read write once, then this access mode, what is the meaning? Meaning is this particular PV can be mounted as read write by a single node, not from multi-node. Read write many means same as first one, but can be mounted as read write by many node. It is by single node, read write by single node, it is read write by many nodes. And read only many can be mounted as read only options, not write options. Read only many nodes. And one more option is there, can be mounted as read write by a single pod. So we have to remember this different access mode. Reclaim policy. Suppose container is down or container is there, but we are going to delete the PVC. Once we delete the PVC, what happen? PV is going to retain, PV is going to delete, and PV is going to recycle. These are the different reclaim policy. Recycle is more or less deprecated. Nowadays we are using retain or delete. So when I delete my PVC, what happened? The PV and the underlying storage are deleted. That means if any data is there, that is going to delete. PV, PVC, everything is gone. But retain, PV remains and the data is preserved. If you want to delete it, then manually you have to clean up it. You have to delete it. Mostly we are going to use retain policy. That is, if anyhow PVC is going to delete or anyhow container is going to delete, still data is available, data is going to retain on the PV. Another option is their storage class. It's an optional attributes. So if it is static or if it is dynamic. If it is static, no need to mention anything. But if it is dynamic, then we have to mention standard or first, used for dynamic provisioning. That is when Kubernetes automatically create it. One more option is their volume source. Volume source, if it is a single node wise, suppose only one node and within this host path, it is just like, suppose this is one node, minikube. Okay, only one node minikube is there, and within this node, that is in OS level, I create /data. And when I create one pod, inside of this pod, I am using one mount point. And I am accessing from that mount point to this data. So this data is known as host path. That is, it is available within this host only. If container is down, host is there. But if node is down, everything is down. It is just testing purpose. Okay, it is just testing purpose. So one option is there, host path option. Single node testing purpose. Basically the minikube. States. When we create the PVC, so PVC is going to connect to PV. PV already connected to storage, actual storage. Now, when we create it and we check what is the status of the PVC, it is showing available. It is showing bound, released, failed. So available means PV is free and not yet bound to the PVC. That is, PVC and PV not linked. PV is there, PVC is there, but anyhow it is not going to linked. Bound means it is linked. That is, PV has been matched with a PVC and is ready to be used. That is, mapping is okay. PV to PVC mapping is okay. Released, the PVC has been deleted, but the PV has not yet been reclaimed according to its reclaim policy. And failed means some error is there. So persistent volume claim. From your container, we have to create persistent volume claim. I am claiming this much storage. So Kubernetes automatically map with a PV. So PVC request, that is persistent volume claim. Now different option is there. You have to go through this. Access mode is there. Resources, storage class, states, pending, bound or lost. Bound means it is okay. Other than bound, pending means okay, you have to wait few minutes. If it is still it is showing pending and continuously pending, that means some issues are there. Lost means connectivity or mapping is lost. So relationship between PV and PVC, that is most important. See, whenever we create any pod, either it is stateful or it is stateless. So normally if you create one just pod, web server pod, just testing purpose, it is stateless. But when any pod related to any storage, that is PV, PVC, then it is known as stateful pod. So in real time, whenever we are going to run any applications, that application is going to use some database, then database data is going to store in storage. Because database pod, maybe anytime it is going to down, maybe anytime it is going to up. But storage, the database, the data, that should be persist. So PV checking purpose, kubectl get PV, describe, get PVC, different commands are there, same as kubectl get pod, get service, like this. Now this is actual scenario, but right now we are going to create one minikube. First testing purpose, one node. Within this we just install minikube, and we are going to create one pod. This pod is going to access one storage, that is within this minikube I am going to install NFS. NFS means equivalent to EFS. In AWS, whenever you configure EFS, it is going to use protocol NFS. Protocol NFS means network file system. Okay. Even this NFS you can configure in another node also. Suppose I create one more node, and here we configure NFS. And NFS shared location is, suppose OPT my data. This is my NFS storage. Now this NFS storage I mounted here in this node. This is NFS server. If you want to check locally, otherwise you can check in AWS. I am going to discuss that portion also. Here it is. This is our NFS client, and in NFS client I just use, suppose, /var NFS. So when I use this NFS client here, what happened? This var NFS and this OPT my data, it is going to map. Okay. Now we are going to create PV and PVC. We are going to create PV. So this connectivity PVC to PV, and then PV to this NFS, and inside of this PVC, that is persistent volume claim to persistent volume to NFS. If I am going to store any data from this particular pod inside of this container, data is going to actually store here. So in AWS also, if you create one master and two worker, and now you launch one launch one pod, and you create PV PVC, and you are using EFS, then data is going to store in EFS. If you delete your complete cluster and again you create the cluster, again you access that EFS, yes, all the data are available. Data is available in EFS. Even you can take the backup also. So what is this? This is completely storage or volume. Okay, storage or volume management. Fine, storage or volume management. So when we use EFS, we have to utilize some particular driver for EFS, and within Kubernetes it is already clear to you. Whenever we want to create pod, deployment, service, PV, PVC, everything is YAML code. Only we have to write the proper YAML code, mention the kind PV, kind PVC, kind pod, kind service, right? Second line of the first line or second line of the each and every that YAML code deployment. So this is complete concept of this PV and PVC. I am going to show you one options in Minikube, and I am going to share if you are interested for the same thing in AWS. Then create your cluster in AWS and create one EFS and access this EFS from your pod, right? And this document is important, that is A to Z of PV PVC internal, all the options. Persistent volume means once your container or pod or everything is deleted, still volume is persist, it is not going to delete. So PV PVC related, this concept is important. Now practically, say this is one Minikube machines. I already configure here NFS. You have no idea how to configure NFS. If you are interested, I will share that portion also. You can create it in the same node or NFS in a different node, your choice, or completely in AWS. Okay, that document, that deployment, everything I am going to share. Now in this machine, check it, Minikube status. So Minikube is running. Now kubectl get node, only one node, Minikube control plane, get pod. In default namespace there was no pod, but if I use -a system pod, then it is going to show all the system pod. One system pod is extra, storage provisioner. Okay, storage provisioner, one extra option is there. Now what is our target? Our target is we have to create PV, PVC, and then we access it. Okay. So in local machine, in this machine, if I use export fs -v, it is going to show opt my data. This is exported. Exported means shared. and shared for world, because when I configure it I use asterisk, that is from anywhere. This is NFS server, you have no idea about how to configure it. So best option, if you continue this practice, go to AWS, or I will share it. If it is possible, you can continue in your local machine also, because we have to complete this NFS options. Once NFS options is okay, NFS purpose, this one as a root, firewall SLinux disable, then DNF install NFS utils. You have to create one directory. In my case it is, I just copy this history command. Then we have to change this within VI export, so you have to write something. What we have to write within this export? Let's check it. cat slash etc exports. Within this I just write this line. Okay, so when you create it, you have to write this one. Before that you have to create this directory, permissions and others. Permissions is full. Then enable NFS server. This is the way you can enable your NFS server. And in fstep file you have to write the local machine IP address, opt my data. This is mount point, NFS is file system and others. Show mount is the command, or export fs -v is the command. You can check. Now we are going to create our PV, PVC and others. Okay, so let's continue. Let's try to check it. So right now if I check kubectl get PV, there was no PV. PVC, there was no PVC. Pod, there was no pod. Deployment, there was no deployment. Before start, I just want to check once more. cd slash opt my data rm minus fabc. I just delete it, clear it. That is my mount point, local storage. Now this is pod YAML, this is PV YAML, PVC YAML. So in one shot, PV all, it is there. Just try to check it and try to understand. PV all. Within this, first I am going to create, what is the kind? Persistent volume, that is PV. What is the name of my PV? PV01. And I mentioned 2 GB, 2 gigs. And read write many. Many actually not required in Minikube, because Minikube single node only. So read write once also okay. And my path is opt my data. and server I use, this is the minikube IP address, and persistent volume claim policy retain. What is the meaning? We already discussed. Retain means if it is deleted, still data is there. That is, if PVC is going to delete, PV is still there. And storage class blank, what is the meaning? It is static, it is not dynamic. Static means we are going to create the PV. Otherwise, we can mention standard, so automatically it is going to create. Once PV is ready, we have to claim it. That is persistent volume claim. I am claiming 1 GB storage. From which PV? PV01. Just now we create PV01. So I am claiming 1 GB from this PV. PV size is 2 GB. I am claiming 1 GB. And my PVC, that is persistent volume claim, this name is PVC NFS, because I am claiming from NFS. You can use any name. Then I am going to access it. Access purpose, I am going to create one pod. My pod name is NFS test pod. And container, specification, container, all the information of the container. Busy box, using one particular image, very teeny image of Linux, and some other arguments are there, but main target is volume. So volume mount, NFS volume, that is the name, and path is OPT my data. That means this pod is going to access this OPT my data. And this is persistent volume claim, name is PVC NFS volume. So if I run this, what happen? First it is going to create PV, then it is going to create PVC, then it is going to create one pod, and inside of that pod we can access that volume. Okay, let's see. So right now we already checked, there was no PV, no PVC, no pod. So kubectl create I am creating using this file. So in this file, PV, PVC and pod, everything is there. So it is showing that PV01 created, PVC NFS created, and NFS test pod created. Let's check. kubectl get PV. It will show one PV is created, size 2 GB, RWX access mode, read write many, RWO read write once, and reclaim policy is retain. That is, if I delete it, still data is going to there. Bound, that means PV, it is bounded with PVC, because in one shot I create PV and PVC and pod also. So bound means PV and PVC is linked, mapped. So just check PVC. PVC also it is showing status is bound. And which PV? Actual PV is PV01 and PVC is PVC NFS. It is bounded. Now if I check pod, it is showing NFS test pod. It is running. Now we have to check Is it possible to access that storage from this pod? How to check it? So from my check it, my host name is PC Mini. Here it is showing PC Mini. From here I am using Minikube SSH. Minikube SSH means I am inside of the Minikube. Okay, now I am in host, that is inside of the cluster. Then we create one directory. Then we mount it. Okay, we mount it. That is this directory mnt test mount with my NFS, that is OPT my data. Once I mounted, I'm just going to create few files in my mnt test, that is inside of the mount point, inside of this port. Now I exit from it and test it from my local machines. So let's check it. From here we have to use Minikube SSH. So right now I'm in PC Mini, that is my host. Now I am inside of Minikube, check it, inside of the cluster. Now inside of cluster, nothing. So I am going to use create one directory under mnt, my directory name is test. Under mnt directory name is test. It is showing it is already there. So I am using test1. Create it. Now once directory is okay, we have to mount it. We have to mount sudo mount. Type of the file system is NFS. My source is my local machine OPT metadata, my data, and my mount point is mnt test1. Then it is going to mount. So this time we have to use test1. It is mounted. Now let's move inside of this. Let's move inside of this. But it is not test, it is test1. I am inside of the test1. Now I am going to create few files. Touch ABC ls. It is showing ABC file. Just now I created. Touch XYZ. So these are the file created inside of my Minikube cluster, inside of that particular pod, inside of the cluster. Now how to check it? We just exit from Minikube to local machine. See, it is in Minikube. Now I am in Minikube. Check it, docker @Minikube, because Minikube running on Docker. Here it is showing docker @Minikube. Inside of this mnt test1. Now my current location. Now from here I am going to exit. Exit means again I back to my local machine. It is going to show my local user kit2 and PC Mini. Check it here. Kit2 PC mini. So exit from here. Exit it. Again I back to my host machine. Now when I'm in host machine, I'm just going to check OPT my data, which is available in this local machines, NFS mount. So let's check it. ls-l/opt my data. Check it. abcxyz file is created here. So when I create inside of the pod, I am created where? MNT test, that is the mount point, MNT test 1 in my case, and it is mounted where? MNT test 1, that is the directory, because PV PVC is created. But actually data is going to store where? In my data, OPT my data. It is one type of host path. But in future you have to create multiple node where? In AWS, one master, two worker, and you have to create one EFS, and you have to create PV and PVC. Suppose one pod is using one PVC, 2 GB of PV, another pod is going to get another PVC, 5 GB of this PV. So this storage portion is little bit critical. You have to understand this PV, PVC and actual storage, and what is the relation, what are the different status. Within this document everything is there, all the status options. What is PV, what is PVC, and different provisioning options, static, dynamic, different characteristics, this read write once, read write many, read write, read only many, different options are there. Reclaim policy, retain, delete, we use retain here. So right now if I am going to delete my pod and recreate again one pod, data is still available, because data is going to available in OPT my data. It is in host machine. If I didn't delete OPT my data is still available. Again I am going to create another pod, and I am going to create one directory and mount it. Okay. So NFS through you can check it. If you understand it, this NFS installation and others, complete history is there, and what you are going to write in exports file, everything is there. How to check it, either show mount or export FS. Then PV, PVC and pod. After create PV, PVC and pod, just now I create it, then move to Minikube and test it. I move inside of the Minikube and test it one by one. This is just first time testing purpose. Okay, first time testing purpose. But industry standard means you have to create this Kubernetes cluster using kubeadm or KOPS or EKS on AWS, and then utilize EFS. So if you use EFS, if you want to use EFS, I am going to share one documents that EFS purpose, how to write the PV and PVC related YAML file, because we have to mention one driver. Without that driver, Kubernetes cannot access the EFS. Okay, that is little bit different, but concept is same. Just your YAML code little bit different. Inside of YAML code, we have to mention that particular driver. So first you go through this concept wise, check the video and check the documentation, try to clear the concepts, then you try it in Kubernetes. Okay. So other than this PV, PVC, I am going to share few other documentations. I am going to share few other documentations that is related to see second part PV PVC. Today we show you list of kind objects. It is completely theoretical options. I am going to share this documentation, go through this. What are the different types of kind or objects? Kind or objects means within your pod or deployment we are mentioning na, kind equal to pod, kind equal to deployment, kind that is service. Now we learn PV, PVC. These are all kind. Kubernetes config map and secrets. What is this? Why this? What is the importance? I'm sending the documentation, go through it. Tomorrow we will discuss it. And tomorrow we try to complete this one. How to create user and how to grant some role, RBAC, role based access policy. Okay, I'm sending this Kubernetes backup and restore. Backup and restore, you know how to take backup of any machines or any files or anything. Here it is backup of the Kubernetes cluster, and if cluster is anyhow some disturbance, we are going to restore it. Backup restore practically is not required because it is not for you. Once your experience is 7-8 years in Kubernetes, then only it is required. But backup restore purpose, you have to know how to take backup, how to restore it, and what should I take the backup. In Kubernetes, what I am going to take the backup, etcd database backup or any other important files backup. Service account, what is this service account, what are the importance, that is also theoretical options, you have to know it. Kubernetes daemon set, daemon means you know httpd, that is the daemon, and when it is running, that is the process. Yes, one more practical is required in Kubernetes, customize. What is customize? Say we completed one practice, one test in development area. Now we want to continue, development test is okay. Now we want to continue the same thing in UAT, that is pre-production. And after pre-production, we are going to continue the same thing on production. But dev, test, UAT and production, configurations, number of pod and others is going to change. So customize, spelling is different, K. It's Kubernetes customization actually. So it is K through customize. Customize means we have to mention such a way, so no need to rewrite the code from dev to test, test to UAT, UAT to production. Same code is there, just little bit change. So no need to write the same code next number of times. Okay, that is customize. Upgradation next week. Different types of upgradation is there. Upgradation not so important, but interview purpose, max search, max unavailable, available, this is important. Okay, next week this upgradation, max search, horizontal pod auto scaling, ingress controller, and then Helm Argo CD one more week, and EKS Prometheus one more week. That is weekend. Saturday, Sunday, Saturday, Sunday. Okay, now Terraform. Terraform, max to max 2 or 3 classes we try to complete it. Then interview preparations, mock interview. Okay, so anyhow within this month or 1 week of next month we will complete it, including Terraform. Fine. Today I am sending this video, these documentations, including this documentation of list of these config maps. Tomorrow this practical. Okay, tomorrow this practical. I am sending this backup restore, I am sending service account, daemon set, customize also I try to complete tomorrow. Next week our target is upgradation. Okay, this is next week. this portion. Now one more options, it is also important. PV, PVC, PV all, where it is? Not this. One diagram is there. Okay, I will check and I will send it. Okay, so this is our next plan. Please go through this. If there are any doubts, don't wait for weekends, because we have to check load balancer also before increase, and toleration and others. One option is there, small options. So don't wait for the weekend. In between, you may update me that we are facing this problem or this. Okay, I will help you. So tomorrow our target is RBAC and customize. RBAC practically I will show you, and customize 50%. That is, I show all the options how it is. If you are interested, you can go through it, because big infrastructure is required. Okay, any questions? Please try it on Minikube. Okay, and if there are any doubts, anything, please update me.
Yes, sir, sure.
Okay. Okay, then bye. I'm sending this video and other documentations. And in your group, please OP. Okay,
Okay.
please OP.
Yeah, sure, sir.
Okay, thank you. Bye.
Thank you.
Thank you.